This is another physics lesson, this time in 2 dimensions. This problem comes courtesy of a paper that you can find for free, and it's about a penguin standing on a rock, projecting its poop a certain distance. This is the version of the problem we're going to use. The penguin butt is 0.35 meters above the ground. It's firing at 30 degrees above the horizontal, with a speed of 2 meters per second. We want to know how far away does the penguin poop land. This image is almost directly from the paper, slightly edited by me. You can see we have our coordinate system with X and Y labeled. We have our origin directly beneath the penguin on the ground. And we can see the angle and speed at which the poop is flung. Based on our coordinate system, we want to come up with qualitative graphs for the position, velocity, and acceleration in both the X direction and the Y direction. And we're only doing this for the period of time in which the penguin poo is flying through the air. And these are the results. You can see since gravity is pointing solely downward, the acceleration is just in the negative Y direction. There's no acceleration in the X direction. Look at these graphs and make sure you understand before we move on. Ordinarily, the next step would be to fill in a chart of all our known values. We're going to do that, but in order to figure out the initial X and Y velocities, we're going to need to decompose a vector. Our initial velocity we know is up at an angle. We know the speed and we know that angle. What we want to get from that is the velocity in the X direction, which is telling us how fast left and right the poop is moving, and the velocity in the Y direction, which is telling us how fast up and down the poop is moving. You can see that we have a right triangle between VIX, VIY, and VI. So we can do some right triangle trig to find that VIX is VI cosine theta. And since VIY is the opposite side from theta, VIY is VI sine theta. Now we can plug in our known values for VI and theta in order to get VIX and VIY. Bottom right is supposed to say VIY equals 1 meter per second. And now we can put all of this in the table. You can see that XF is unknown, and that's what we're trying to solve for. If we only knew delta t, XF would be easy to solve. So we have to find delta t. The only equation that has delta t as its only unknown is this one. But it doesn't solve very easily. As we arrange this equation, we see that it's a quadratic. So what we're going to do is plug in our values with it arranged as a quadratic in t squared. Now we're just going to plug that into any quadratic solver, any polynomial root finder, and we get the roots 0.388 seconds and negative 0.84 seconds. The negative would be before the penguin even pooped, so delta t must be 0.388 seconds. Now all we have to do is plug our delta t into the X equation to get XF. A lot of those are 0, so we plug it in and we get 0.671 meters away. The original paper found a much more far-flung poop, but I think they had the penguin starting higher. This is a silly paper with some good physics in it. I recommend you give it a look. There's some fluid dynamics, there's some viscosity, and of course there's this kinematics. It's a pretty fun read. The link will be in the description.